Hello everyone, my name is Aisha Chiandet and I'm the water scientist with the Severn Sound Environmental Association. And I'm here today to tell you a little bit about the Severn Sound Area and the Environmental Association that I represent, as well as delve into the who, what, where, when, why, and hows of water quality monitoring, which is really the key to keeping our waters safe and healthy. So to start us off, where exactly is Severn Sound? So this picture here shows a satellite image of the Great Lakes, which you're familiar with. And if we zoom into Georgian Bay and looking at the Midland area, that little collection of bays down at the south end is Severn Sound. So the Severn Sound watershed encompasses all of the tributaries and lands that flow into Severn Sound. So we have 7 major tributaries, including the Severn River, which comes in at the north end. There are many interesting features within the watershed that are important to monitor and protect. So we have lots of provincially significant wetlands and inland lakes in the area. It's also a very unique area in terms of geology and geography because the transition zone between the Canadian Shield and the Great Lakes St. Lawrence lowland basically splits right down the middle of Severn Sound and into Severn Township. So there's a lot of biodiversity hotspots and natural heritage that are important to protect. So why do we monitor water quality? If we go back to about the mid-1960s, Severn Sound was actually in pretty rough shape. So people likened the water to looking like pea soup. We had blue-green algae blooms and filamentous green algae in the mouth of a lot of the rivers and tributaries. And Severn Sound was actually listed as one of the 43 areas of concern, or AOCs, on the Great Lakes. So we have 17 of these AOCs that are in Canada. And right now, across the Great Lakes, 9 of the AOCs are either listed or are in recovery, and 5 of those are in Canada. So Severn Sound was actually the second AOC to become delisted in 2003. And this was because of a lot of work that was done through our remedial action plan to remediate a lot of the issues that were going on in the watershed and in Severn Sound. And so it was important to monitor water quality to identify the problem in the first place, which was highly related to nutrients and algae growth and habitat degradation. And it's important to continue monitoring to make sure that we see those improvements are continuing and that we don't slip back to previous conditions. So when we look at monitoring water quality, we can sort of partition it into the human health side of things and the ecosystem health side of things. So in terms of human health, water quality is important to monitor for both drinking water and swimming safety. So we want to make sure that waters are clean so that people can drink and not run into issues because of bacteria or contaminants that can cause disease. In terms of ecosystem health, monitoring is important to ensure that water is clean for both terrestrial and aquatic ecosystems. Monitoring really allows us to sort of look at water quality over time and in different areas within Severn Sound and its watershed. So these graphs show some examples of long-term water quality monitoring of indicators that give us a sense of the nutrient status of Severn Sound. So the different colored lines and dots here represent different sites all across the Severn Sound water body. And the top left-hand corner, we have total phosphorus, which is really important for controlling algae growth and plant growth. And you can see that the concentration of phosphorus has come down dramatically since monitoring began in the early 70s. And in terms of conditions now, the dotted lines here show the remedial action plan targets that were set. And so conditions now are meeting those targets, which is good to see. Another indicator is the amount of nitrate that comes into the water in the spring, which has actually been going up in a couple of places. So for indicators like that, that's something that we want to keep an eye on and keep investigating. The bottom left-hand graph shows the amount of algae in the water. And so this, as I mentioned, is very closely tied to phosphorus nutrients coming in. So we can see that it's declined along with phosphorus declines. And then the final graph on the right is showing SSEA depth, which is a way to measure how clear the water is. And so we really have kind of two periods, distinct periods in terms of water clarity. So the earlier period, there was a decline in water clarity up to a certain point in the mid-90s, and then we had a shift to much clearer water, and since then water clarity has been declining again. So it's important to measure these kind of indicators to be able to explain why things are happening the way they are and predict what we might see in the future. So this is just showing where some of these breakpoints in the measurements are in terms of time. So some of the impacts, the positive impacts we've seen on water quality have been related to controls that were implemented through the remedial action plan. So things like upgrading wastewater treatment plants in some of the larger urban centers, Midland, Penetanguishene, Belleville. There were a lot of upgrades to private septic systems and implementation of urban stormwater treatment, which was important. There were a lot of projects for agriculture, so in terms of livestock fencing, to keep livestock out of streams, tree planting projects, shoreline restoration. And so all of these things collectively had a very positive impact on water quality, but you can only see that if you regularly monitor the condition of the water. And there are also implications of larger ecosystem changes on water quality that, again, you really only see if you're measuring it on a regular basis. So as we saw in the previous graphs, where water clarity changed really dramatically in the mid-90s, this is exactly the time where we had an invasion of zebra mussels. So they're first reported in 1993, but really quite widespread in the mid-90s. So now we have both zebra mussels and quagga mussels shown on the right there. And they really sort of created a large dramatic change in the water quality of Severn Sound. So when we're looking at water sampling in general, in terms of where we take these water samples, it sort of depends on what exactly we're interested in and what questions we're trying to answer. So if we're interested in drinking water sources, so say from a municipal standpoint or for our association measuring long-term change in groundwater quality, we would monitor wells in the area. So we have our water quality sampling wells. And then in terms of drinking water, we also measure surface water. So there are some communities in Severn Sound area, Victoria Harbour and Port McNicoll, for example, that use surface water for drinking. And so we help to measure the quality of that water as well. Rivers and streams are important to monitor, as well as lakes, so not just Severn Sound, but also the smaller inland lakes in the area. So across Severn Sound itself, this map shows all of our water quality monitoring sites. And you can see the circled sites here have been measured every single year since 1973. So we really have quite a good data set for Severn Sound. So in terms of what we're monitoring when we go out there, I've touched on a few of the variables already. So we measure things like the nutrients, so phosphorus, nitrogen, and carbon that's in the water that sort of provide the basis for growth of plants and algae. We'll look at things, physical and chemical characteristics, so things like temperature of both lakes and streams, pH, conductivity, which sort of measures like the amount of dissolved stuff that's in the water, how clear the water is, as I mentioned before, the amount of oxygen that's in the water. So different fish and invertebrates will have different tolerance for the amount of oxygen in the water, and they can't survive if it's too low. So that's important to measure. And then we also have food web indicators, so algae and zooplankton, which I'll talk a little bit more about in the next slide. So when we look at sort of a basic lake food chain in Severn Sound and the components of it that we want to monitor, as I mentioned, we start off with the pool of nutrients that's dissolved in the water, so the phosphorus, nitrogen, and carbon, which then supports a given amount of algae growth in the water. And this algae will in turn feed zooplankton, which are these tiny microscopic little animals that float around in the water column. About 2 millimeters would be the largest one you'd find, so they're quite small. And they really go to town on the algae and kind of keep it in check. And they in turn support the plankton eating or planktivorous fishes. So you have your sunfish, things like that, or juveniles of larger fish species, which will in turn get eaten by the larger fish. So the bass, the lake trout, salmon, all that kind of thing. These are your piscivorous eating fishes. And really, if we see issues in one part of the food web, so for example, declines in zooplankton, then that's really going to impact the food chain levels above and below it. So when we bring it back to our human health versus ecosystem health in terms of what we monitor, there's a lot of overlap there, but then there are differences as far as measuring things like bacteria, obviously more important for the human health side of things. So for drinking water and swimming safety, we want to measure things like E. coli, harmful algae, so such as blue-green algae in the water, things like sodium, which can come from road salt and can become an issue in drinking water. Also heavy metals, so things like copper and lead that might be in the water. And other contaminants such as PCBs or pesticides, and even microplastics are starting to become an issue. On the ecosystem health side of things, we have things like temperature and oxygen, as I mentioned, important for fish survival and invertebrates. Nutrients that support the algae and plant growth, and then things like chlorides, which also come from road salt and can start to have an impact on invertebrates and zooplankton. And then similarly to human health, in terms of protecting fish and wildlife, we want to make sure that water is free from heavy metals and other contaminants that might cause harm. So in Ontario, we do have standards and guidelines that are in place to protect both drinking water safety and aesthetics, so like how the water tastes and smells, and guidelines that are in place to protect aquatic life. So there's some examples listed here, so things like nitrate, important in drinking water, phosphorus guidelines that sort of protect against excessive algae growth in lakes, streams. There's chloride guidelines for both the drinking water and aquatic life perspective. Oxygen, as we talked about, so cold water fish and warm water fish will have different thresholds that they can tolerate for oxygen. The amount of so how kind of murky and muddy the water is important, obviously, for drinking water. You don't want to drink something that looks like chocolate milk, or changes that might occur because of turbidity in natural waters can be detrimental for fish and invertebrates. And then finally, bacteria. Obviously, we don't want any bacteria in our drinking water. And then there's a threshold of 100 for beaches and swimming safety. So in terms of when we monitor water and take water samples, again, sort of depends on what areas we're looking at and what questions we have. So some examples here, if we're looking at ecosystem monitoring in Severn Sound, we go out and sample every 2 weeks, and it just sort of gives us a general sense of how the water quality is. For stream temperature and looking at how that might fluctuate with air temperature, we need measurements a lot more frequently. So we use little data loggers that are put out in the streams, and we'll measure temperature every half an hour. Looking at something like drinking water, municipalities will test drinking water on a daily basis and a weekly basis to make sure that it's safe to drink. And for beaches, they're sampled generally once a week, sometimes more often, to make sure that E. coli levels are low enough for swimming safety. You can see it really varies depending on what exactly we're focusing on. In terms of how we actually sample and test water, there's lots of different equipment that we use that will measure water sort of in the field. So on the right-hand side, we have a probe that can measure the amount of oxygen, temperature, conductivity in the water. On the top photo there, we have some composite water samplers that allow for the sampler down to a certain depth and raise it up, and then sort of get a picture of or a sample of that water column. So these samples will then send away to a lab for analysis. Our lake sampling is done by a boat or canoe, and river and beach sampling are done just by wading right into the water. And that last piece of equipment there, the SSEA disc, which we've talked about, which allow us to measure the water clarity. So our last question here in terms of who monitors water quality. So obviously the Severn Sound Environmental Association plays a large part in measuring water quality in the Severn Sound area. But there are other government agencies and municipalities that also do water quality monitoring as well. So for example, the Ontario Ministry of Environment, Conservation and Parks does regular sampling, every few years they'll come up to the Severn Sound area. But also the one that would respond if there's a spill, an oil spill or something like that in the water. Environment and Climate Change Canada also does some monitoring in the Georgian Bay and Severn Sound area. On a more regular basis, the Simcoe-Muskoka District Health Unit takes care of beach water quality sampling. And then the various municipalities across the watershed are responsible for testing drinking water and making sure that it's safe. And then finally, homeowners and citizen science can do their part in water quality monitoring as well. So the health unit recommends that well owners sample their water at least 3 times a year and send samples to the health unit for E. coli testing. And then citizen scientists can also take part in volunteer monitoring. So SSEA does have a couple of citizen science-based water quality monitoring programs, and you can find more information about that on our website. And so I'll leave it there to close. You can visit our website there for more information on the programs that we have that people can volunteer for, or just learn more about our monitoring programs. And we're also on Instagram and Twitter. And I would like to thank you very much for listening and your attention.